some additional problems. We have a preceding video of this where I actually wrote things out as I talked about them. This will go much faster in case you need to be brief, and that's typical. So we have started with just a blank board here. I just drew the set of coordinate axes. Said here's your graph region. We're going to put 1 here, about halfway between here and here, a little less than halfway, because we actually want to be able to get out to 2 here. And same here. So we have the point 1, 1. And on this graph then, we are going to sketch y equals x to the p curves for various y factors. We'll verify again, if x is 1, then x to the p is 1, so y is 1, so the point 1, 1 goes on this curve. Now, if your y factors, I want you to sketch these curves, construct these curves for y factors 1/2, 3/2, 2, 5/2, and 7/2. You've already constructed the 3/2 and the 5/2 curve, but you want to add the 1/2, the 2, and the 7/2 curve. Okay, then we want to estimate the curves based on the picture you get from these 5 curves for y factors 3 and 4. And I'll let you think a little bit about how that would be done. Okay, now, then having done that, for your estimated factor 3 curve, we want to use that to estimate the values, the y values, on that curve for x equals 1/4, 1/2, and 2. Then, on a separate graph, because this one's going to be pretty cluttered, I want you to carefully construct your factor 3 curve and estimate f of 1/4, f of 1/2, and f of 2. Now, f of 1/4 is just the y value you get when x is 1/4, so that would ideally match the value you got here. But it's not going to match because you won't have located this curve perfectly. You won't have done this one perfectly either. There's bound to be some discrepancy unless you just traced over this curve, in which case you completely lose the whole purpose of this exercise. Okay, or at least this part of the exercise. So anyhow, we estimate f of 1/4, f of 1/2, f of 2. Again, these values will be close to, but probably will differ in some way from the values you got here. Then we want to compare these. Presumably these are going to be more accurate than these. Well, we want to check that. So, the factor 3 curve, we're actually going to do some, I'm going to let you do some calculations, and you're going to use your calculator because you can't do these calculations reasonably by hand. You would need a table of logarithms and all sorts of things. You just couldn't do the arithmetic in any reasonable time. Couldn't even learn to do the arithmetic in reasonable time because it's very complex. Okay, so we're going to use the calculator. This is an appropriate use of the calculator in a world where there are all kinds of inappropriate uses. We know that the factor 3 curve, and hopefully you proved this. Hopefully you have proved this, but maybe you haven't. Doesn't matter at this point. I mean, it's better if you have than if you haven't. You can still use the result that your factor 3 curve represents x to the log 3 divided by log 2. The power p is log 3 divided by log 2 for this curve. Okay, so we can use this. You can get log 3, you can get log 2 in your calculator. You put a number in for x and do x to the log 3 divided by log 2. So that's what we want to do. We want to evaluate f of x for x equal 1/4, 1/2, and 2, and compare that with previous results. In other words, compare it to this and this. Ideally, your results here would be more accurate than your results here, but it won't necessarily work out that way. Either way, you're going to learn something. Okay, then your factor 2 curve has a very specific shape. Now, this is not related to what went before. It's a new question. The factor 2 curve has a very specific shape. When you drew it, you probably saw what the shape would be, and you maybe saw why the shape would be what it is, because it becomes apparent as you construct the curve. So what is this shape? Okay, what is the shape of the factor 2 curve? And having constructed it, you should have an idea why it's so. Can you think through why it's so and then actually prove that it's so? That's a little bit of a stretch, but not a big one. If you really understand why, then you should be able to come up with a reasonable attempt at a proof. And you hopefully come up with just an airtight proof, okay? That would be great. But you start by thinking about why is it. Okay, another question. There's a difference between the factor 1/2 curve and the others. My question is, what is that difference? Okay, what's the difference between the factor 1/2 curve and the others? Something you can say about that curve that doesn't apply to any of the others. Then, what's the limiting value of y for this factor 1/2 curve as x approaches 0? Okay, now, to complete our picture here, of course, there are infinitely many values between these fractional values here. Some of them are whole numbers and some are irrational numbers and so forth. But one obvious curve that we might want to think about is the factor 1 curve. So if you can sketch the factor 1 curve, it'll show you maybe more clearly how the factor 1/2 curve fits in with all the rest. And then one additional question. The question is, why is it that the factor 0 curve is undefinable unless 0, 0 is declared to be your starting point? For example, we've used 1, 1 for the starting point on all these curves so far. Why is it that if we use 1, 1 as the starting point, we get something rather strange? And what is strange about it? Is it a curve? And let me clarify something over here, that in some cases here, you might get straight lines. Okay, if you get a straight line, well, is that a curve? Well, it doesn't curve, but a straight line is still regarded as a curve. It's just a curve with no curvature. Okay? Okay, well, go to it. These are pretty profound problems, and the whole idea of proving things again is really something we want to be working with.